Hello, everyone. Thanks for joining us. Welcome to the Co-op Innovation Network and our first publicly facing event, webinar number 1 in our Ideas for Innovation series. As a brief introduction, let me tell you a little bit about Co-op Innovation Network. We are a new organization founded in August of 2024, and the Co-op Innovation Network endeavors to unlock the potential of rural electric cooperatives across the nation to drive energy solutions, grow job-creating regional energy economies, and advance policies for local energy democracy and energy justice. Our first webinar is titled The Orchestrated Grid. In this session, we will explore how rural electric cooperatives are deploying grid orchestration tools to manage increasing loads of renewables while also improving reliability. We have 3 fantastic panelists for you today, and I'll go ahead and introduce them. First, we have Stephen Breesley. He's the VP of Strategy and Marketing at Camus Energy. Steve leads strategy and marketing at Camus, which is a software provider for grid orchestration and flexible interconnections. Prior to his work at Camus, Steve helped large U.S. utilities develop grid modernization strategies while he was a consultant at Bain & Company. And he designed flexible data center solutions at Vertiv. He's based in Chicago and hails from Indiana, a proud Hoosier. Stephen is going to discuss the broad landscape of orchestration of flexible resources. He's going to share the basics of how grid orchestration allows for integration of more renewable sources and highlight some challenges and opportunities for co-ops. Next, we have Ben Brosnan, the Director of Solution Engineering at Virtual Peaker. Ben earned a Bachelor of Science in Electrical Engineering from the University of Kentucky and a Master's of Business Administration from the University of Denver. He has 10+ years of experience in the energy industry, holding various roles at Schneider Electric, Uplight, and now Virtual Peaker. Throughout Ben's career, he's worked with clients to identify their overall needs and system requirements and acted as a bridge between sales and product teams. Currently at Virtual Peaker, Ben's team is focused on educating utilities on Virtual Peaker's software functionality and how it can best meet their DERMS needs. Solution and proposal development, device partner management, and helping to develop sales and product strategy. Ben is going to share services and platforms allowing for grid modernization among cooperatives and discuss the process to implement these solutions through Holy Cross Energy. That brings us to our final presenter, Kimbrel LaRoche. He is the Distributed Energy Resources Specialist at Holy Cross Energy. Kimbrel's goal at Holy Cross Energy is employing the use of more solar energy and battery storage on the grid in a manner that benefits the entire membership. Alongside managing Power Plus and Power Plus Flex, Holy Cross's 2 energy residential battery programs on a day-to-day basis, Kimbrel is researching new grid technologies, member-facing program concepts, and other methods that have the potential to drive Holy Cross Energy towards its renewable energy goals. Kimbrel then integrates his findings along with the other Holy Cross Energy specialists into actionable programs and projects. Kimbrel is going to share why Holy Cross decided to pursue grid orchestration, how deployment has benefited co-op members, and some challenges that have come through this process. With that, I'm going to turn over the presentation to Stephen. Thank you very much.
For sure. Thank you, Ted. Thank you, Kinsley, for showing this, and thanks to everybody for inviting me to be here. So as Ted mentioned, I'm Stephen. I lead strategy and marketing with Camus and have been with the team here for about 5.5 years. Prior to that, I had some background on the grid mod side and solar plus storage project development. So today I really wanted to focus this conversation around grid orchestration and specifically some of the challenges related to load growth and the growth in renewables as well. We can go ahead and go to the next slide. So why does orchestration matter for cooperatives? I think historically, utilities broadly across the United States, not just co-ops, but the larger utilities as well, have typically had planning and operations based around a more kind of worst case scenario planning approach. And the ability, really, the gold standard is being able to plan a system that doesn't break, and that when there are storms or there are challenges, there's quick response from the operational team. But now co-ops are starting to see a lot more load growth. They're starting to see data centers, manufacturing, in some places EVs. Generation is shifting towards more variable renewables. And broadly, what this means is that the supply and demand dynamics are becoming a lot more variable and shifting quite a bit faster. And so when we talk about orchestration, I think what we're really talking about here is the shift to kind of a more proactive planning and operations model that is dealing with changes really quickly, that is providing more flexibility to grid operators and grid planners as they're adapting to all these. And so orchestration really offers the ability to dynamically adapt both flexible demand and the supplier generation to deliver on affordability, reliability, sustainability, and increasingly this obligation to serve new members and new loads. Next slide. So I think at its most kind of simple level, orchestration really means boosting three utility capabilities that already exist but need to grow in order to be a truly kind of orchestrated grid. So one of the pieces that we see all the time is a focus around real-time awareness and forecasting. So if we think about true grid orchestration, what does it really look like in this sort of ideal world for utility? Being able to monitor real-time and forecast your grid conditions in one place is really important. It's also about being able to dispatch or even sometimes just bound these DERs and these large loads to manage and mitigate against these grid constraints. And so when I think Ben's going to talk a little bit about some of the DERMS areas and what it looks like to that, to be able to dispatch these devices and to do so in a grid-aware way, that is a really important part of this orchestration vision. And then the part that's often the most, I think, kind of underappreciated when it comes to orchestration is really more on the planning side. And for utilities to be able to react and to be able to pull flexibility into their the kind of normal way of operations, they need to have that built in from the planning side, because there's no point in being able to try to use the flexibility to shift around constraints if your planning team is building the system big enough that they aren't relying on that in the first place. And the real savings from an affordability standpoint and from kind of optimizing the system comes when the planning and operations teams are both building with this flexibility in mind. We can go to the next slide. So one of the challenges I think that we see when it comes to actually operationalizing orchestration and to bringing it into a co-op is that on the left side, pretty much every utility has some mix of these systems like GIS and the kind of geospatial mapping of the grid. There's AMI or some sort of way to bring back meter data from the individual members' meters. There's outage management systems, there's SCADA, but these are systems that are generally pretty siloed from each other. So a planner and operator has access to data, has access to information, but they're in different places. And then on the far right, you have different ways of managing devices and managing kind of flexibility in the system. So some of these are SCADA controllers for like a large solar or battery system the utilities operating themselves. And sometimes it's a grid or an edge DERM system that's managing member-owned resources in conjunction with certain programs. But often there's this missing middle of being able to say, if you want to be able to say, orchestrate EVs to not overload transformers, or orchestrate a data center to not overload a substation transformer or a transmission line, you have to be able to pull together that core utility data with the ability to see and understand and dispatch those resources on the edge of the grid. And that's really what this middle kind of buckets are focused on, is building that kind of composite grid model, pulling that data together, and then having the dynamic planning and operating capabilities. So we don't have a ton of time to go into too much detail here, but that is one of I think the big pieces of orchestration is really going from these separate systems to something that can flow all the way through. Next slide. All right. This slide is meant to be kind of scary and intimidating, and I'm absolutely not going to talk about any of the boxes on it. But I think one of the most kind of underrated pieces here when it comes to grid orchestration is that grid orchestration at its core is largely a data problem of there are all these data silos, there's all these systems that need to be able to speak together if you're really going to orchestrate. And so typically this data architecture is one of the more underappreciated challenges. So that's not to say that it's not possible or that it's particularly difficult or even that it's too crazy to do. I think the reason that it matters that people appreciate the data challenge as being a challenge is because it builds up the importance for what you're going to focus on. So I'll jump to the next slide and make this a little more clear. I think often when we talk to co-ops, whether it's a board member, whether it's a general manager or CEO, there's buy-in pretty quickly towards the idea of orchestration and towards the idea of having the grid all kind of run together and smoothly, and you have bill savings, you have more reliability of all these things. But that vision doesn't deliver the new capabilities that really make up orchestration. Instead, what really delivers it is finding specific urgent pain points that the utility is feeling, that the members are feeling, and solving those in a way that is consistent with this orchestration vision. And so I think Kimbrel and Ben will both talk about some of the different pain points that they've been working around and some of the things that they've been solving. But for Camus, I think we're really focused on 2 pain points. So we'll jump to the next slide. Those 2 are data center load growth and lack of generation capacity. So on the data center side, it's really like, how do we get these data centers in when they can just be absolutely enormous and feel pretty overwhelming for a co-op that's trying to figure out, like, is it really going to happen? How are we going to build this in the system? How do we not build in a ton of cost that maybe gets stranded by the data center not showing up? So we're helping try to tackle that problem. And then the other piece is really on this renewable side and the surge in renewables of how do you get generation onto the grid in a way that's going to fit and work with existing infrastructure. And so co-ops need safe, fast ways to connect both these loads and renewables. And the solution that we're focused on and kind of the use case of orchestration in this case is largely focused around flexible interconnection. So I think about maybe a minute or two left. So we'll jump to the next slide. I'll run through this quickly and then happy to answer questions at the end. All right, so 2 left. Flexible interconnection. I think this is a concept that I'm more than happy to talk about in more detail with folks. But typically, when we think about whether you think about a data center or whether you think about a large solar generator, when you're going to plug them into the grid, the way utility planning paradigms are set up is you're looking at worst case scenarios. And so in the case of the chart on the left, the black is the capacity on the grid. And then that purple line is based on what is the worst case scenario for the year. And so if that's all the capacity you have available at a certain time, that's how much load can be connected. It does the same thing sort of on the generation side, just flipped. And so these traditional interconnections are really focused on worst case planning and on the system being robust so that you don't have to have as much of a real-time management lens for all of these different devices. Next slide. What a flexible interconnection does is it really is trying to unlock the rest of the space between what was that purple dotted line and the black line and say there's more capacity on the grid that we can use if those resources are flexible. And so for a solar generator, that might mean curtailing. For a battery, it might end up being kind of shifting when you're using it. Or for a data center, it may even be using some on-site generation or energy storage to be able to help fit within the grid. But the idea is you're able to get these resources connected years sooner and avoid the co-op having to build out a bunch of infrastructure for these individual resources, which benefits all members by bringing affordability benefits to all. So I'll jump to the last slide here. So Camus, we're pretty focused on this planning and operations piece for flexible interconnections. This is just one part of the orchestration vision that we wanted to focus and thought might be complementary to what Kimbrel and Ben were talking about. But it's also, I think, the biggest opportunity that we see for the subset of co-ops that are seeing data centers and solar really starting to grow. So if you do have questions, we've got time at the end. I'm also happy to take questions sort of outside of this medium as well. But thank you very much.
Thanks a bunch, Stephen. Appreciate that. Let's move on to Ben. Ben's going to share with us services and platforms that allow for grid modernization among cooperatives and discuss the process to implement these solutions that they've used with Holy Cross Energy. So there's some overlap there. We'll pass it over to Ben. Thanks.
Awesome. Thanks, Ted. Go to the next slide. So, Stephen talked a lot about how to do grid orchestration front of the meter. I'm going to focus more so behind the meter and how you can manage various devices using a virtual power plant software. So at a high level, Virtual Peaker is a virtual power plant provider that currently operates with 40 different utilities across the United States and Canada. About 45% of them are currently cooperatives. We do also work with municipals and IOUs. This is just kind of a map showing the various places we work with today. Then going to the next slide. To help enable our cooperative clients to manage all these behind the meter assets, we also integrate with a bunch of different manufacturers. We currently integrate with over 30 different manufacturers across a broad set of device types, including thermostats, water heaters, EV chargers and EVs, and then batteries. And then we integrate with, at this point, about 90 to 95% of the market share across these different device types. And then we continuously add integrations over time based on client feedback. So this is definitely not a static list going on here. And then going into the next slide, within Virtual Peaker, we provide a platform for utilities to manage all those behind the meter assets. And then we structure this platform into 3 different suites to help kind of simplify and manage all these different devices. Kind of big aspect of our software is what we call the shift suite, which is really doing all the device controls. This is how cooperatives can call events and manage devices. So Holy Cross uses our platform to manage batteries and EV chargers, for example, as well as see all the device data that comes along with that and all the reporting analytics. And then another big aspect of managing all these different device types is engaging in the members and getting them enrolled into the programs. So we also have a relay suite that offers enrollment portals, program landing pages, and messaging that's all directed to members to help get them engaged and enrolled in programs. And we always white label everything to utility branding and however they want to brand programs. And then lastly, our Envision suite provides forecasting tools for cooperatives to help make decisions on overall load forecasting, on when's like the best time to call an event, and then overall event forecasting and see the overall amount of load you're looking to either shift or discharge for an event based on whatever device control you're doing. And then moving to the last slide, kind of underneath all the technology, we kind of structure things by 3 major product principles. The first one is APIs for everything. So we try to make everything very accessible and easy, both from an integration standpoint and from a data standpoint. So we have APIs for new device partners to really easily integrate into our platform, APIs to easily integrate up into other types of platforms. Could be like a grid therm system, data system, AMI system. And then we also have APIs available for cooperatives to use to pull data very easily, call events through other systems, and pull different reporting into like a Power BI. So you can do different data analysis. And then the second big principle we use is self-service. So our platform is designed for the utilities to use on their own and do everything themselves. I know from all the cooperatives we work with, this is something they very much like and use all the time. They like being able to call events when they want and having a platform that's super easy to use. It also helps reduce cost and saves time across the utility to have the utility people actually managing these devices themselves. And then lastly, our overall vision and goal is to make all behind the meter assets as controllable as a gas turbine. And that's our top line demand control product, which allows utilities to call for an overall capacity, say like use large numbers, say they utility needs 100 kW, they could call that on the top line, and then our system could automatically control those devices to deliver that 100 kW. We're thankful to work with partners like Holy Cross who are kind of testing out this new product to see how it works, providing a lot of feedback to help us make continuous improvements and keep kind of delivering on the ability to control these assets in one place. With that, I will toss it over to Kimbrel.
Thanks, Ben. Thanks, Ted, for having me here. Yeah, I'm Kimbrel LaRouche. I'm with Holy Cross Energy. I've been here for about 3 years, and I'd just like to take the opportunity to talk about how we got here in our renewable energy journey. And so to start off with the next slide, we are a cooperative in Colorado, about 46,000 members and 65,000 meters roughly. And as of late, just this year, we were able to supply 80% of our power being renewable energy, which is part of our goal to supply 100% renewable energy by 2030. So to get there, we're employing a number of grid orchestration technologies, which is why we're here today, along with member-facing programs and some other things I'd like to talk about. So next slide, please. So as I was saying, energy efficiency, we're starting there just to limit the amount of power we need to procure, prevent the need for costly electrical system upgrades, and reduce the financial impact of electricity costs on our members. Then moving forward to the power supply side, we're procuring cleaner wholesale power. We've brought on a number of projects such as a wind farm on the Front Range outside of Denver, and then a number of on-system resources, including solar and batteries. And we're looking to those to really articulate our load and generation to fit the times when renewable energy is producing and when our load is increasing. And then third, we're working with our local communities to develop clean energy resources that can directly connect to our distribution system and provide energy resilience as they provide affordable clean energy to our communities. And then fourth, and this is really where I start to come in, we're providing a number of distributed energy resources through member-facing programs, such as batteries and electric vehicles. We're directly orchestrating those through things like virtual peaker and driving a lot of member participation with our power supply that way. And then finally, we're employing smart electrification, encouraging the use of electricity for transportation. We've installed level 3 electric vehicle chargers throughout our grid in a lot of very key locations. So moving on to the next slide, please. So our progress to date, we actually earlier this year hit about 93% or in the low 90% renewable in the earlier this year. I think it was May. And then by the end of the year, we're expecting to be around 80% entirely. So well on our way to 100%, but it definitely doesn't come without its challenges. And then actually go next 2 slides. I'm going to skip over in the interest of time. Those are just a couple pictures of some of the larger scale resources we brought online. So this is our hourly load in July of 2024. A lot to unpack here, but you can really see our financial drivers. There is a thin red line about halfway through the month, a vertical line, and that shows our coincident peak. That's the financial incentive Holy Cross is chasing that drives all of our member-facing programs, some of which I'll talk about a little later. So things like demand response, batteries, but then also this kind of shows you how we're going to use our batteries and well, really our batteries to shift the generation into those evening and peak hours. I believe the slides will be passed around later, so you can really dive into the colors here and see exactly what's producing where in the intricacies of our power supply. Moving on to the next slide, another thing in the spirit of transparency, I can also give you our power supply roadmap, which really gets into even more of how we're planning to get to our 100% renewable goal by 2030. But in the interest of time, I think I'll keep going. I want to leave plenty of room for questions because I'm getting into the cool stuff. So in 2019, we started this project with Basalt Vista Housing is a Basalt Vista housing project in partnership with gosh, I can't remember. This was before my time at Holy Cross, but the key point here is that there were 4 homes, all with orchestrated DERs. So we could actually share energy between these houses in an islanded state with DERs such as batteries, solar, an electric vehicle charger, and heat pumps, all coordinated together. So it's kind of like an energy sharing setup. And really what we're driving at here is what can the future of the electric grid look like if you expand something like this to a whole neighborhood or even a whole town and city. And this was really the start of our Power Plus program. So moving on to the next slide. This is the battery storage program that we launched after the Basalt Vista housing project. And now we have about 5 megawatts of power walls and other battery storage residential distributed across our grid. And we're using these batteries to chase that red line that I talked about, that coincident peak. So basically, our wholesale power provider is going to charge us a lot of money for every megawatt we draw when their system peaks. So essentially, what that boils down to is we're trying to predict when our wholesale power provider's system peaks, and then we're discharging distributed batteries during that time, and we save a lot of money through that, and then we pass those savings on to the members in terms of bill credits and on bill financing for power walls, and then other efforts to chase that peak involve just standard demand response, also EV charging curtailment and delayed slash managed charging, but a number of programs that really fit into that orchestration category. Moving on to the next slide, a little bit about our EV charging program. Something else we've been doing is experimenting with bus to grid. Mixed results there, but I think the lesson learned is we're not quite at the point where we can reliably, the technology is not quite there, but it's good to get these lessons learned. So just something that we're dealing with as a programs team, trying to figure out how we can leverage not just the residential EV chargers, but the commercial EV chargers, things like bus, and we're dipping our toe into vehicle to home with residential systems. All in all, we're finding that the technology isn't quite there, but I think there is just absolutely huge potential, especially when you consider that one electric vehicle could have a 200 kilowatt hour battery, which is vastly beyond what one residential stationary storage battery might be, like 5 kilowatt hours or 10 kilowatt hours. Moving on to the next slide, we also have a number of rate and program options focused around our tariffs and our rates. So starting at the top two, the Distributed Energy Resource Service Agreement and the Distribution Flexibility Tariff, those are kind of the foundational building blocks of Power Plus, and I'm happy to talk about more on that if we want to dive into the questions. And then moving on, peak time payback and green up. Peak time payback is kind of traditional demand response where we're just sending a notification to our members. It's a simple notification, just a text message or an email. I personally like to get them just to keep tabs on the program, but the email just says, hey, reduce your energy usage during this time frame. And then we compare the energy reduction and put a credit on the member's bill valued at nearly 15 times the retail electric rate. So about $1.50 per kilowatt hour. Then the Green Up program is kind of like the opposite of peak time payback. When renewable energy is super abundant, we send a message that says, hey, use a ton of energy right now because it's super cheap, that kind of thing. And we can give you a super cheap rate for any energy that you use when we have oversupply. And then time of use, pretty straightforward there. And Pure, also another pretty common program for cooperatives to have. Just if you sign up for the Pure program, we'll make sure that all your energy comes from renewable sources. So with that, I think I'll leave it to questions.
Yeah, thanks. Thanks, Kimbrel.
Looks like we got some in the chat.
Ben, Stephen, yeah, there's some questions in the chat. Additionally, anybody who has questions in the audience, raise your hand and